is going to be difficult. So, good evening, everybody. I think everybody can hear me, right? Yeah, okay. So, a warm welcome here in Amsterdam. This is our office, GoDataDriven. So to speak, our dome here in Amsterdam at the Wieboudstraat, also called the Knowledge Mile. We have a lot of techie companies here at the Wieboudstraat, and I would like to give you, a warm welcome by introducing GoDataDriven. Today, as being GoDataDriven, we're hosting the meetup for Dataiku. Now, hopefully, you'll have a lovely evening. A little bit more about us. Who's familiar with GoDataDriven? Has anybody heard of Xebia or GoDataDriven? Yeah, okay. Oh, so lots of them. Okay, so thanks. So we're a data science company established like 5 years ago when we started experimenting with Hadoop. That was 9 years ago, but the company itself was founded 5 years ago within the Xebia Group, which is a full-service IT company within the Netherlands that is focusing on, let's say, digital transformation. So from security to software development, but also data science and engineering. So that's the part what we're doing. We're based in Amsterdam with, it says 30 specialists, but we're almost 35 now. Next year we'll go to 50. With data engineers and data scientists. And the thing that we do is that we try to help companies become more data-driven by, on the one hand, build scalable platforms that allow data scientists to actually build something into production, and with engineers helping to make it more robust and more sustainable to the future. Well, as said, part of Xebia Group. Well, this is something that I'm really proud of. Lots of these labels that you know, of course. Like KLM, we're helping them with predictive maintenance models on the components that they have installed in aircrafts. But also, for instance, at Transavia, where we do waste reduction, looking at the fresh products that they have on board while having a flight, trying to reduce the waste over there by having these models in place. Maybe something about the mission and values at GoDataDriven. Well, you see these people, they're actually colleagues of mine, and whatever we do, we try to be the #1 authority within the market. So try to go for the best of the best, not only by looking at the consultants that we have working at GoDataDriven, but also looking at the projects that we engage with. So whatever we do, we always want to productionize the models that we're building. So very often, I'm quite sure that you recognize this, you have companies that work on models that, let's say, retain into a proof of concept modus or a proof of value modus and not actually productionizing it. So when we try to help companies become more data driven, we always say go to production. You can do a lot of experiments and maybe 80% of them will fail, but at least bring the 20% into production so that you can actually get the value from it. And the key values, sharing knowledge, so that's what we're doing right now. This whole building has been built with the purpose to share knowledge, not only within the company, but also with a lot of people outside of the company. So we do these meetups like almost every day. So it's always very busy here at the Wieboudstraat. Customer intimacy, so it's not about working really closely together, but more that we're on the same level, on the same page, and that we know what to expect from the customer and that the customer knows what to expect from us. Quality without compromise. We do something great or we just don't do it. So I already told you we try to productionize everything that we do, and that's really important to us. So when we start a project, it should be of the, let's say, the highest quality that is possible, or else we just don't do it. There's no compromise between it. And the last one, people first. My thought is, the consultants are our biggest assets. So really the consultants, let's say, determine the technology that we're working with, also determine the partners that we're working with. And Dataiku, I think, is one of the partners that our colleagues are really enthusiastic about. They gained a lot of experience working with Dataiku, and we can see real big traction within the market now that the companies try to use the tooling to become more data-driven towards the future. So.
People first is the 4th on your list.
Yeah. Yeah, but it's not my sheet actually. Maybe that's it. Okay. So, but yeah, talking about people. So, if you have people in mind, data scientists or engineers that that can join us, please let us know. It's a very short meeting. Yeah, so again, we're hiring data engineers, especially data engineers. We're looking for data engineers. So if you know them, bring them to us. Data scientists and growth hackers, just let us know. Happy to get acquainted. And then I would like to give the word to Hielke. Warm welcome, Hielke. But before I do that, could I please ask you, if you bring in your glasses, just take them with you to the bar when you go outside, so that the people over there don't have to clean everything. And for the rest of the evening, I wish you a joyful evening. So thanks.
Thank you, Dennis. Yeah, as Dennis already said, my name is Hielke Visser. I joined Dataiku last year. I'm basically starting up the Dutch business, and yeah, one of the things to validate the company a little bit, I made a call to GoDataDriven and say, hey, is there any future for this product? Should I join them? And they said yes. So we became partners, and we do regularly now the meetup. So thank you for having us here, Dennis. Tonight we're going to talk a little bit about O16N. Makes it easier, of analytics, and we have two great speakers here today. We're going to start with Longhow. Longhow has been active in the data science space for the last 16 years, but he was one of the first ones in the Netherlands start working with Dataiku, and he's always kind of first one who's picking up new releases, and he likes to develop a lot of things and prototype a lot of things himself, but as well to see how can we operationalize analytics in an easy way. So I'm very happy that he will talk about his project that he built himself, and he's going to explain a little bit the approaches to it. Next to that, I'm proud as well to have here my colleague from our Paris headquarters, Harizo, over here. Harizo, a data scientist working daily with customers, and as well focusing on getting data science into production. So he will share a couple of his practices from his past years working in this space. So it's about two talks, about around 40 minutes. If you have questions, group is small enough. I heard there were some issues with the traffic here today, so not everybody could join. Group is small enough for asking some questions, but I think it's best to, especially we do live streaming tonight, I think it's best to collect the questions till the end, so you can get a mic, so we can record it as well, so the people who are watching online can follow it as well. So with that, I would like it over to Longhow for his first presentation.
Yeah. Can everybody hear me? Okay. Oh.
Yeah.
Okay. Oh. Yeah. Okay. Thank you, Dennis and Hielke, for the introduction. My name is Longhow. It's quite easy to remember. It's how long in English, and then you have to switch it around, and that's Longhow, and my surname is Lam. I'm a freelance data scientist. If you have any projects, just call me. Today I'm going to talk about house prices and how to deploy a house price model with Dataiku. So the agenda is why Dataiku, and then Jaap.nl, it's a Dutch housing site where you can get some nice data, to build a house price model, and also Jaap.nl text mining house price model. And I'll dive into that. Why Dataiku? 2 years ago, I started with Dataiku because Yilke asked me, Longhow, do you know Dataiku? I said, I'm using R, I don't need tools like Dataiku. But I started to become a freelancer, and I saw teams of data scientists struggling. And why? Because as an individual data scientist, you're not struggling, you're using the coolest tool, Python or R. But as a team, it becomes something different. And many challenges I see, and there are so many machine learning and languages, machine learning kits, H2O, R, Scala, Scikitlearn, TensorFlow. Nobody knows them really all in depth, right? And also in a team you have different levels between seniority. You have senior data scientists, you have junior data scientists, and you also have to work together with businesses, departments that maybe don't know data science, and deployment of analytical results. Not only a predictive model, but what about visualizations and dashboards? And that's where I started to fall in love a little bit with Dataiku, because it offers something that's called horizontal collaboration and vertical collaboration. And in a team, you always have multiple data scientists that work together on one project. And you need to keep track of who's doing what, otherwise it becomes quite of a mess. We all know models that have been created by Python or R developers, 1,000 lines of code. That becomes tricky to maintain. It becomes even more difficult when in a team there's a vertical collaboration needed, like a data engineer, a data analyst, a data scientist, and someone from the business. Now then you really need a tool that can keep track of all the work that is done, and at different levels. So I found it quite nice to have full coding capabilities, that you can code in R or Python, and that the code is managed by Dataiku. Powerful data preparation, visual machine learning techniques, and data visualization, all in one tool with a nice graphical interface, a flow interface, so that you can keep track as a manager of a data science team who has done what, and you can deploy results quite easily. So as a data scientist, you would be working as a data analyst in the Data Science Studio. I'll show you some screenshots later on if you want to create a model. Then, of course, if the model is created, you need to deploy it. That can be done in 2 ways. Batch runs, let's say every month or every week you need to score a batch of customers. Or, and I will show you that later in the presentation, real-time scoring by deploying models through a REST API. And of course, you can connect to many different data sources. At the SVB, the Sociale Verzekeringsbank, we're using Dataiku with MariaDB, for example, but you can connect to any data source. It makes use of the infrastructure that is already there, and you can use that. So, a little bit introduction why I think Dataiku is cool. Now to the use case that I have. I never get data from real companies to show other people, so I have to create my own data. And one of the sites I like most is ja.nl. Maybe they get a little bit tired of me because I'm scraping them regularly. But if you buy a house in the Netherlands, you can go to ja.nl and look for a house. There are around 140,000, 135,000 houses that you can scrape. And what do you get then? You get a price column, so that's a vraagprijs, the asking price, and some features of the house, like the living area, vrij op naam, that means is it a new built home or not, the postcode, a province, type of house, like a villa, a penthouse, or a farm. And can you now predict the price given these features? First of all, to get an impression of the data, you can just create some visuals in Dataiku. You can plot the location, and you can see here the Amsterdam effect a little bit, some high prices, and here in Groningen, in the east of the Netherlands, there's some lower prices. Quite easily created such a plot, and easily deployed as a dashboard if somebody else needs to look at these plots. Some other variables that you can easily create, some other plots, like the living area against the price. Obviously, the larger your house, the more expensive it is, except there's a lot of noise here. And also, if you plot the price by home type, you see a villa on average, well, the most expensive type of house. And then here, an apartment or a recreational home is the least less expensive house. Now that you know a little bit of the data and you want to create a model, because let's say you have a house for which you want to predict the price, given the features, how do you put all these variables into a model? That's quite easy. In Dataiku, there is a nice interface around a couple of machine learning engines. Scikitlearn, you can make use of H2O machine learning, or you can make use of Vertica or Spark MLlib. I've chosen for Python, Scikitlearn, because just on my laptop, just the most convenient one to use. The only thing you have to do, select the target. In this case, it recognizes price as a numerical target, so it will do regression. And the other variables, you can switch them all on by default, or if you really want to ignore certain variables, you can turn them off. Then you need to select an algorithm. Scikitlearn, most of the Scikitlearn algorithms are available through this interface. And by default, you can select them all on if you want to, and if you have a lot of time, you can wait for all the models to run. Within each model, let's say you do a random forest, you can set some hyperparameters. You can type them in manual, or you can select a list. Let's say I want to have maximum depth of 3 from 5 until 100. Dataiku will automatically use cross-validation to search for the best hyperparameters from this list that you've selected. Then click on run. What will happen is you can get some cup of coffee and all the models will run. You will see this live in action. Each dot is a hyperparameter and it searches for it. And at the end, there is a champion model. In my case, an XGBoost model with the highest R squared. That's the metric I've chosen. There are other metrics that you can choose from. And you see a linear regression has a little bit less predictive power. So you have a model now. How does the model work? What are the parameters in the model? Let's say we select the linear model. It's the most simple model, but it's not the most predictive model. But to get an idea, so from my data set, I set apart 10,000 houses, and I've got an R squared of around 0.57, which is not bad. But I can explain to other people how your house price is predicted. So you start off with 24,000 euros as a sort of starting point. And then say your first 2 digits of the house is 10. That's in Amsterdam. You add 240,000 euros. 96, that's the earthquake area in the Netherlands. That's minus 103,000. So you already get into the minus sign. Of course, there are more postcode areas, but I've just listed 4 examples. Then you go, okay, what type of house do you have? Let's say you have a villa. You add 173,000 euros on top of what you already have. And then, what is the living area, the number of square meters? Let's say we have 100. Then we get, well, 200,000 euros extra. And then for each extra room, you have 4,500 euros. So let's say 5 rooms, it becomes 20,000 to 22,500. So it's a very explainable model, and it works reasonably well. Of course, this is not the best model. The thing is, the square meter price in Amsterdam is not 2,000. Any broker can already tell you this is more around 6,000. So you can add some interactions if you want between postcode and square meters, for example. But then you're doing some extra feature engineering. You can do that manually, but I've chosen to use XGBoost because that's a nice model which does some automatic feature engineering and has the highest R squared in this case. if you don't have a linear regression model, but say other models, in Dataiku, there's a nice way to get an idea of how the model works. I will tell you a little bit later about Lime, but in Dataiku itself, suppose you have a random forest, you can always see, okay, what are the important variables of the model? And you can see the surface, the living area as the most important one. Inside a random forest, you can look at some of the trees, or all if you want, just browse through those trees so you get an idea how the random forest works. And the Dataiku will give you automatically the predictions on the validation set and the training set so that you can plot and visualize the predictions against certain variables. Let's say price against predicted price. An ideal model would be a straight line, of course, but you see some outliers and you can further investigate why that is happening. Very easy to get a feeling, get an understanding of the model. Here's another. Per type of home, I've created an histogram of the error of the prediction. And then I see these strange things here. And I say, oh yeah, I forgot to remove some outlying values, for example. So it's quite easy. It's in a few clicks, you get these plots and you get an idea of the quality of the data and the quality of your model. Now, okay, suppose I've got my XGBoost price model. And now what? It's a nice model, it lives on my laptop, but I want people to start using it. Otherwise, the model becomes really an academic exercise, it becomes useless. So what can Dataiku do to help you deploy the model? It supports the creation of a REST API within a few clicks. Deployment of the APIs can be managed. You can have a fleet of servers, or you can have a single server, just your laptop, to serve the model. There's an optimized scoring code for most of the Scikitlearn models. So if you have an XGBoost model or another Scikitlearn model, it doesn't use the original Python code, but it's optimized Java code so that if you get a prediction, if you want a prediction from the model, it's very fast. And I'll show you some timings later on. It's secure, it's scalable. You can test and manage many different APIs and API versions, because one model is not always, you don't make one model. Often you make more and more and more models and different versions, and you need to manage that. So how does that look? How does that look in a Dataiku setup? Well, first of all, you've got your Dataiku server, which is quite easy to install. You can go to the Dataiku website and download it and issue this command in your terminal, and then you have the Dataiku Studio installed. But then you need two other components, the Dataiku deployer. With the same downloaded binary, you install the deployer with just -t API deployer, and then you select a directory and a port. And you need the Dataiku API nodes. These are the actual components that will serve the HTTP request. And with the same installer, you can install the AP node, just -t API, specify a directory and a certain port, and you're set. You're ready to go. So how does the setup look like? As a data scientist, you're sitting behind your laptop creating the models on the Dataiku server, and you can push them to a Dataiku deployer, which will manage a fleet of nodes where the actual model is served. And to give you an idea how that works, we're now on the Dataiku Studio as a data scientist. I've got these different models. Let's say I have my XGBoost model, a random forest, and I click on New API Servers. You give it a name, let's say linear model or XGBoost. You enter a unique endpoint, XGBoost for example, and you select what to deploy. It could be a prediction model, one that I created earlier, but it can also be a custom R function, an SQL function, an SQL query. It can be more than just a model. And then if it's a prediction model, you can select here the model that Dataiku has created. Let's go for the XGBoost model. And of course, I use optimized scoring. Then if you click that, you go to push to the API deployer. So the model, the package, will be pushed to the API deployer. And what do you do with the API deployer? The API deployer has a separate interface, and in that interface you can manage the models, the infrastructure, and test and create test runs for your model. So you see here I have on DigitalOcean, which is just a cloud computing environment to spin up some Linux machines. And I have also on Argeweb, it's a Dutch hosting party. So you first need to create a new infrastructure here. It could be a Kubernetes cluster, but if you have just normal machines with Dataiku installed, it is a static Dataiku API node. You give it a name. And if you've done that, within the API nodes, within the infrastructure, you need to specify where your API nodes live. So you give it an address of your physical machine and a key for security. And then you're ready to go. So you have your models. These were pushed from the Dataiku Studio to the Dataiku deployer. And let's say we pick an XGBoost model and click on deploy. You can set up a deployment test production street if you want to, but you've just now deployed an XGBoost model. You see the different colors. This one is down, orange. This one is up and running. You see the different versions on which infrastructure it runs. And now you can test it. So let's pick one. Give it some input parameters. Let's say I want to predict the price of a tussenwoning, 6 rooms, living area of 134 square meters. Vrij op naam 0, that means not a new home. And postcode 16, that's the lovely city of Horen, for those who know the Netherlands. And you get a test result. This is the price that's predicted. And you can test the API. And then it's up and running. Any client now can call the model. This is actually live running. If you go to this address, it's on DigitalOcean, it's really running now. So let's do a curl command with this address and these features of the house, and then Dataiku will give back this result. Now if you change postcode to 10, instead of Horen, you will go to Amsterdam with the same features. It jumps from 241,000 to 607,000. So it's nice, just exactly the same house, predicted a little bit different price. And that's up and running. You also get timings. This is an XGBoost model with 500 trees. And within 200 milliseconds, the prediction is returned. Even on a crappy DigitalOcean machine. I've just spun up the cheapest DigitalOcean machine, 1 core, 1 gigabyte of RAMs, nothing special. So I'm fairly confident that this can serve really a lot of requests. And if that one machine fails, you can just spin up by pushing 100 of those machines, and Dataiku will manage that for you. So if I don't expect that my house model to get millions requests per second, but suppose I do, I can just spin up more machines on DigitalOcean or any cloud platform. Now, before I go to text mining, I want to do a small statistical experiment, since we're all data people. Can you shake your hands? Can you shake hands with your neighbor? Okay, there are 2 statistics that I'd like to share with you. First, 50% of the people do not wash their hands after the visit of the toilet. So who of the left or the right side was it? A second statistic, to make you feel a little bit more comfortable, 83.1% of the statistics are just made up on the spot. So that's another statistic. I had scraped house prices and features of houses, but there's another, and I used structured data to predict the price of a house. But there's another nice piece of information that you can get from Jaap. That's the description of a house. This is Dutch, but there's also English, but I've focused on Dutch. Each house has a description. Het royale en gezellig familiehuis, blah, 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 blah. Can you use these descriptions to predict the price of a house? You can, and quite good, to be honest. The code, by the way, is given on my GitHub. I will share the slides anyway, so you will see this link. How does it work? I was not able to scrape all the 140,000 house descriptions. After 10,000, it blocked me. I tried again, it blocked me, and then I get fed up. I stopped it. So sometimes they block your IP if you scrape them too heavily. But what you get is, from these descriptions, you can create a so-called term document matrix. You have the price. You have house 1 until house 65,000. And each term in the description is put here in columns. So this house number 1 has 1 times the term aanrecht, 0 times big garden, grote tuin, and so on. There are many, many terms, more terms, but just a small fraction. Originally, I had something like 200,000 columns.
A quick question, why is the grote tuin? Because then you already entered the participation.
Yeah, I make use also of 1 grams and 2 grams. So the software can scan for 1 grams and 2 grams, and even more, but yeah. So the most simple model to fit here is a regression model, linear regression. Just use this as y variable, the target, and these variables, these are just variables, as x as inputs. The only problem with that is there are too many x variables, often more than you have rows, and that's always a problem. So some kind of regularization is needed, and what I've done is a so-called lasso regression. So it's basically linear regression, but then subjected to a certain conditions. Your parameters cannot grow too much, and that's the most simple form of lasso regression. That can be done in Dataiku, and the whole text mining thing, there is an interface for text mining in Dataiku, but I'm an R programmer, so I want to create some R code or Python code. And in Dataiku, that can be done with managed notebooks. In Dataiku, there's a managed notebook environment. It's just a Jupyter notebook environment, but with a little bit extra. Each notebook can be, you can add tags, and you can add little descriptions, and you can see who has entered, who has modified the notebook, and when. It's a little bit extra flavor and organized into a project. And for the rest, it's just Jupyter notebook environment. So I promised someone to show code also. Dataiku is not all about clicking. This is the code for creating the term document matrix in R. My favorite package in R for text mining is now text-to-vec. It's a preparation function to transform everything to lowercase, remove non-alphanumeric characters, and multiple spaces, just remove them with 1 space. Then mutate the huisbeschrijvingen to so-called normalized text, where you do these transformations. I have a list of Dutch stop words. There's an R package. You can enter yourself if you want. And then the nice thing about text-to-vec is you tokenize the words. You create a vocabulary, and here you specify the n-grams from 1 to 3. And you prune the vocabulary. If you create a vocabulary, there are many, many words, more than 500,000 words, and most of them are non-informative. So words that occur very less, or words that occur too often, can be pruned by this command. Then to get a view, just create a simple word cloud first. I know some data scientists don't like word clouds, but just to get a quick impression of the words, badkamer, woning, keuken, etc. And now that you've created this vocabulary, you can create this term document matrix. This matrix with all these different columns. And in R, there's a package, there are many packages that can create a lasso regression. One of them is GLM net. You specify the X, this is the complete matrix, the DTM train called here, the target, and certain parameters. And then a type of measure, mean absolute error, for example. How does it work now? You've got a model. The R squared is 0.66, which is not too bad. Suppose you have a house that you want to score through this model. You start with an intercept. Let's say the average price in my data set, 238,000 euros. Now suppose that you have in the description family house. Then you add 60,000 euros because it's just normal regression to this. But if there is a word in the description that says plinten, these are the wooden stuff here below, then you subtract 22,000 euros. And so you scan the whole text, and each word will enter somewhere, and then you add or subtract a certain value. So now you see here, yeah, the most important, the most expensive words in a text of a house. So, vrijstaand villa, that's very costly. Belegging, that's investment. If a house is described as investment, it's quite expensive. But if it's 2-room, kunststof kozijnen, now you already feel that that's plastic, that's not really expensive. You subtract. Now, this is a nice explainable model, except this is, again, not the best predictive model. XGBoost, again, is the best predictive model. So I also fit an XGBoost, and I can get my R squared a little bit higher, 0.72 on the validation set. And it's also one short piece of code to fit the XGBoost model. You specify again the train and the label, and let's say 50 rounds of XGBoost training. Then you get to 0.72, except it's a black box. But there's a nice package, Python and R, that's called Lime, to open up the black box a little bit. And Lime stands for Local Interpretable Model Agnostic Explanations. There's a little bit piece of mathematics behind it, but it boils down to you need the explanation for a specific house. You cannot, like a linear regression model, have a global one explanation of all the variables. So you need a specific house, let's say the point of interest, and you sample points near that house, near that observation. And the further away, the less weight it gets, because it fits locally a linear model, and a linear model can be explained. So the assumption is that any machine learning model can be approximated locally by a linear model. That's the assumption. That's not too bad assumption. So how does that work? You make a regression model, XGBoost regression model, and you create a so-called Lime explainer, and with that explainer, you can explain certain houses. Now, let's take a low-priced house and a high-priced house, just at random, and explain it. You can get a tabular form. So this is the low house. It predicts the house as 129,000 euro. This was the actually predicted house with the XGBoost model, but your local linear model predicts 130. So there's a small mistake. But you can now see the regression coefficients of the different terms. And again, kunststof, woonkamer, laminaatvloer, that's plastic floor, it's not very expensive. That contributes to the low price of this. Let's take a more expensive house, something in the range of 600,000. Then throw that to the text mining XGBoost model, and what are the words that make up for this higher price? It says woonboerderij, gastenverblijf, vloerverwarming, vide, etc. So still for every house, even if you run it through an XGBoost model, which is quite a black box, you can still get an explanation why the XGBoost model has come up with this price prediction. Now, at the moment, the Lam can only be accessed in Dataiku through a Python package or R package in Jupyter Notebooks, but there is also a plugin. Dataiku can work with plugins, and there's a plugin coming up with a Lam already in an interface, in a graphical user interface. So for the real data scientists who like to code, maybe that's not needed, but for the people who like more clicking and... Okay, that was my slides. Thank you. Any questions?
Yes, I have a question.
Yeah.
I think everybody can hear me.
Yeah.
But
You can repeat it as well.
Yeah.
for live stream.
Yeah, of course.
Yeah, my question is, what was the distance of the kind of what houses are grouped together in the Lam?
Okay, I see. Yeah, because I used a term document matrix, you can specify different distances. By default, it's just the Euclidean distance, but here you can also specify cosine similarity, for example, which is more common to use in term document matrix.
Thank you.
And suppose you would like to deploy what you just written in the R code in Dataiku. Is that possible? Or,
Yeah, because the text mining model is essentially also an R call to XGBoost. And in Dataiku, you cannot only deploy built-in machine learning models, but also any R function, any R code can be deployed. It's not optimized Java code scoring then, because it just calls the R engine. So you might need to take that into consideration, but it can be deployed just with the same steps.
excellent. And if I would like to have a model which I continuously update based on new data, then how does that work?
Suppose I have, well, for now this is just batch learning. Suppose I've got new houses, I can rerun the whole thing, but I'm not making use of online learning techniques or Bayesian updates. The nice thing about Dataiku deployer is the API automatically logs a lot, and the log files, Dataiku Studio can automatically recognize, import that. You would expect that, of course. It can create all sorts of visuals from that as well.
Thank you.
Yeah. A question there? Yeah.
Yeah, sorry, I have two questions. One, does Dataiku handle missing data? And if so, how can you change that?
It can. Within the graphical user interface where you create models, there are certain options. Well, you can leave them out. Sometimes that's not even a bad option. You can impute them, and you can impute a certain value. There is debate if imputation is really a good method, because, for example, suppose you have a categorical variable with male and female, it can impute for the missing the most occurring level.
And then you have bias, yeah.
Yeah, I don't think that's really good, but you could.
Okay.
Yeah.
Thank you. And let's say that you wrote your code in Jupyter Notebook. I assume you have to store your data again after you transform it, and then you load it from the Dataiku, or there's a way to just call the function that will do the transformation?
Yeah, there are certain possibilities. Inside the Dataiku interface, you can extract data from databases or from flat files.
Yeah.
From the GUI, you can import that data. And the Jupyter Notebook, it's not only a Jupyter Notebook, but it also has additional packages created by Dataiku to facilitate the import of data that you already have in your Dataiku environment.
But something like the house prices that you did, you transformed it in R.
In R, that's in
Then,
memory then.
if you want to take this transformation and pass it to
Dataiku?
XGBoost, for example,
Yeah.
do you need to store this data transformed and then load it? or can you just call this transformation function after you load the data from Dataiku?
It doesn't need a separate, it doesn't need to be stored separately. So if you have the data in memory, you apply R, which is of course in memory, then you apply this transformation, and you can run the XGBoost on it.
On this
on this set.
Okay.
Yeah.
Thank you.
So you probably had two projects in Dataiku, one for the text model and one for the more traditional model on the house prices. Is that true?
No, you can have one project where you can have a flow for one model, a Jupyter notebook or multiple notebooks doing certain stuff, but they can be organized into one project. Let's say the house project. You can separate it.
Yeah, because I'm asking because, for instance, if you have two data scientists working, one using the text approach, one using the other approach, and then later you decide, well, they both are quite interesting, but I would like to ensemble them, for instance. Can you then join them together?
You can manually in code, because the one model is just a code model, and the other model, that's quite funny, by the way. The models that you create in the Dataiku interface, and let's say you choose for Scikitlearn machine learning engine, that model, Dataiku calls the machine learning, the Python code under the hood, and you can get that code. So it's also available to you. It's not just a black box where it says random forest, but if you click on it, right click, and then export to Python code, you will get a notebook with the code. So and then you can combine it. There's no magical button that says combine the Jupyter notebook and the other model, but it can be stored in one project. Yeah.
Okay, thanks.
Okay.
Thank you very much again.
Okay.
I think we can go for a break for like 10 minutes, and then we go for TikTok. Thank you.
Thank you.
Mute, now you're live.
Okay.
So maybe Jack and... Okay. Yeah, can you talk maybe a bit longer?
Okay, check.
Yeah, it's good.